Good afternoon. This is Dr. Subramaniyan from Velamal Institute of Technology. Today we are going to see about bus admittance matrix, which is used in power system network to determine the parameters in the given network. So bus admittance matrix is denoted by Y bus matrix. Y will be in a capital form and the bus will be in the suffix. So the bus admittance matrix consists of two major admittance, and one is self admittance and second one is mutual admittance. So self admittance is also called as driving point admittance. So self, in the sense, it consists of only self admittance value, and mutual admittance is also known as transfer admittance, so which is between the two buses to transfer the admittance value. So for deriving the admittance value, we have to know the impedance value. In general, impedance is equal to R plus Jx. R is nothing but resistance and J is nothing but reactance. So from this you can determine the Y. Y is equal to reciprocal of my Z. So Z is impedance. So when we are applying the Z value in Y, 1 by R plus Jx, by mathematical formulas and mathematical calculation, we will get Y is equal to G minus JB. So we have to take the complex conjugate is R minus Jx and divided by R minus Jx. After the calculation, you will get Y is equal to J into JB. Here G is called as conductance and B is called as susceptance. Now this bus admittance matrix is very much useful in the load flow analysis to determine the network parameters, and it is also used in the stability analysis to determine the stability of the system even after the small disturbances or large disturbances. And when it is going to the sparse matrix, so sparse matrix is called as, it consists of n number of zeros or maximum number of zeros. So when it is a sparse matrix, your calculation will be very much simple. And it will require less memory to occupy the system. So these are the applications of my bus admittance matrix. For calculating bus admittance matrix, we have two methods. First method is direct inspection method. And the second method is singular transformation method. So in these two methods, the most commonly used method is direct inspection method, but the singular transformation method is rarely used method, but it is easy to calculate the bus admittance matrix for the given network, because in singular transformation we have many sparse matrix, but in direct inspection method we don't have any sparse matrix. Now I will teach you how you can calculate the bus admittance matrix by means of direct inspection method. We will solve one problem to determine the bus admittance matrix value. So this is the problem which is I have taken. So the parameters of a 4-bus system are as follows. So the bus code, line impedance in per unit, and line charging admittance in per unit. See, there are total 4 buses are there. So bus number 1, 2, 3 and 4. 4 buses will be there. And the line impedance represent the impedance value between the bus 1 and bus 2. And the line charging admittance represent the admittance value of the corresponding bus or corresponding line in the network. So now we want to determine the bus admittance matrix. What is Y bus matrix? Here we want to determine this is the requirement for the given system. Now you can see there are 4 buses, so maximum value will be 4. So the output of this bus admittance matrix will have a 4 cross 4 matrix, Y12, Y13 and Y14. y21, y22, y23, y24, y31, y32, y33, y34, y41, y42, y43 and y44. So this is the output of my question. So y1, 2, 3, 4 and all self or diagonal admittance, remaining and all non-diagonal admittances or transfer admittances. For diagonal admittance, we have a formula to determine y11, 22, 33 and 44. The formula will be yi is equal to summation of j is equal to 0 up to n. N is nothing but number of buses in the system. Yij, where I is not equal to j. Here I and j represent, I will be the row value and j will be the column value. So this is the formula for diagonal admittance determinants. Then now we'll solve it for one by one. Now I will go with y11. So y11 is equal to we have to determine y12 plus y13 plus y10. That is, you have a data of y12, y13 and the line charging admittance is nothing but y10. So it is a impedance value. So we have to go with 1 by. We have to take the reciprocal of this impedance and you will get y12 is equal to 1 by impedance value of bus 1 and 2 is 0.2 plus j 0.8 plus y13 is 1 divided by 0.1 plus j 0.4 and y10 is nothing but line charging impedance of the bus number 1, line charging admittance of the bus number 1. So we have two buses connected with bus number 1. So j 0.02 divided by 2 plus j 0.01 divided by 2. We have to add the half line charging value, then only we will get the line charging admittance value. Don't add the full value as it is given in the question. So when we are solving it in a calculator, we have to switch on the calculator and make the mode as complex mode, and you will go with step by step procedure. First you will go with 1 divided by 0.2 plus 0.8i. So the value will be the real part will be 0.294 plus the imaginary part will be, the imaginary part is 1 divided by 0.2 plus 0.8i. So the imaginary part is minus 1.176j. Likewise, we have to put for the remaining term also. Now we will go with second term, 1 divided by 0.1 plus 0.4i. So you will get 0 plus 0.588 minus 2.3529. Then j 0.01 plus j 0.05. Now the total answer will be 0.882 minus j 3.514. So likewise we have to go with y22, which is y22 in the sense impedances connected with the second bus. So y21 plus y24 plus y23 plus y20. When we substituting all the values, you will get it as 0.862 minus j 3.072. Likewise y33 is 1.215 minus j 4.49 and y44 is 0.529 minus j 2.088. This is for diagonal part. If it is for non-diagonal part, for non-diagonal elements, the answer, the formula will be yij is equal to yj is equal to minus of yij, which means y12 is equal to y21 is equal to minus of y12. So the bus number 1 and 2 will have an impedance of minus of 1 divided by 0.2 plus j 0.8. So you will get it as minus 0.294 plus j 1.176. This is the value of y12. Likewise, you have to determine for all the non-diagonal elements. If it is, see, you have all the connections between 1, 2, 2, 3, 2, 4, 3, 4, 1, 3. But there is no connection between bus number 1 and bus number 4. So the value will be y14 is equal to y41 is equal to 0. So there is no connection between bus number 1 and bus number 4. Likewise, we have to go with all the diagonal elements and all the non-diagonal elements. Finally, you will get the y bus matrix value as I am writing here, 0.882 minus j 3.514 minus 0.294 plus j 1.176 minus 0.588 plus j 0.2353 and 0 minus 0.294 plus j 1.176, 0.862 minus j 3.072 minus 0.33 plus j 1 minus 0.235 plus j 0.941 and 3 minus 0.294 plus j 1.176 minus 0.33 plus j 1.25 minus j 4.49 minus 0.29 plus j 1.17 0 minus 0.235 plus j 0.94 minus 0.29 plus j 1.17 0.52 plus j 2.8. This is the value of the entire y bus value. This is how we can determine. So when we are solving the bus admittance matrix, we have to see whether the question is given in the admittance value or in the impedance value. If it is given in the impedance value, we have to convert into admittance value and then we can determine the answer. If it is given in the impedance value, admittance value, you can directly add the given values and you can determine the y bus matrix. Thank you.